Let's suppose we draw a simple straight line, such as we have here. And from this, we want to see if we can make an equation that would apply for any number beyond this beyond this area, forward to the right or backward to the left, as far or as much as we wanted. What is the universal equation for this simple line? Before we can answer this, we need to construct the idea of a plane, an xy coordinate plane, where as far as we go to the right, the x increases, or as much as we go upward, the y increases. And then from that, we needed to overlay the xy coordinate plane over the line in a way that makes sense to us, in a way where we can then break it down logically from the way that we arrange it. Here we see where you can put this line over top of the coordinate plane. Like I was saying, you need to do it in a logical way. It's best if you make it so that your y coordinate, the up and down line, the up and down white line, has an overlap point that is flush, that is even with or in line with a whole number. In this case, it's the third line up. The reason you're doing that is that it just simplifies it. If you had like a 2.5 or a 2.7, it wouldn't be as easy to work with. So once you line it up like this, now you can make an absolutely universal equation. We see that our points here are 2, 4, 2 for the x, 4 for the y, and 8, 7. 8 for the x, 7 for the y. From this position, we just need to find out the very first thing is the rise over the run, or which is also called the slope. And you take this by taking the difference of the y's first, which is 7 minus 4, and then taking the difference of the x's, which is 8 minus 2. And from this, we can do the math on this, so that 7 minus 4 is 3, and 8 minus 2 is 6. We can see easily that we have a rise over run of 1 over 2, meaning that as you progress upward 1, you have to progress over 2 to the right, which is the idea of rise over run, or the idea of slope. Before we go farther, let me show you that slope, and then I'll show you the actual equation. Here you can see better with this close-up zoom that the line slopes 1 upward and 2 to the right, and that's where we get the 1 and the 2. This means that this actually means that it's a slope of 1/2, 1 over 2. So this is our equation here at the top now. Y, which is correlates to the y coordinate, equals m, which is slope. X is on the x coordinate, plus b, where b is the intersection point on the y coordinate. I know I kind of just presented that all together. The first thing that we know is the m. We know the slope. We figured that out already, 1 over 2. So below there you can see where I put in 1 over 2 in for the m. Everything else we can just figure out now by looking at or calculating with normal algebra. For the b is just a matter of counting. We're going to take, 1, 2, 3 up. That is the intersection point on the y-axis, the y coordinate, is 3. So we're going to put in for the b just the number 3. So now that we have that, what you have here in this formula is really a sentence. And the sentence says that if you can find y, you can find the value of y, if you calculate half of x plus 3. So what that means is if you take any x times that so that it results in being half, take half of that x and then add 3, from the x information you're going to find out your y information. Now just simply all equations can be stated as sentences. Let me say it one more time. If you want to find out y, you can find out y by taking half of x and adding 3 in this instance, in this equation. So the number I'm going to choose to test for the sentence is I'm going to try the number 2. It's kind of a tricky reason why I'm trying it, but we're testing out to make sure that our equation is correct, that it lines up, that this is truly an equation for the line that we created. So if I take the 2 and I put it in for x, I'm going to get 2 times 1/2 is going to be 1, and then add 3. In the next part, I'm going to show you here why I chose 2, because y now we know equals 4. The 3 plus the 1 equals 4. And the reason that I chose the 2 is because that's one of our initial starting points, 2, 4. 2 is for the x and 4 for the y. So if this is right, we know that because 2 and 4 is already one of our starting points, that our equation is right, that our straight line equation works, that it isn't, there's no mistake in it. Now we're just going to verbally check the last one. Again, the equation is that we said from before. If you want to find out y, take half of x and add 3. So half of x in the 8, 7 on the top right part, half of the x is 4 plus 3 equals 7. So just verbally looking at it, then we can see that the 8, 7 is correct. So if at least 2 are right on our straight line equation, and we're testing it, and the numbers that we started out with work out in this equation, then our equation is right.